Loops are a programming control structure, which we use to make things happen multiple times. So if you find yourself writing the same code over and over again, probably copy-pasting it, and making only a few tweaks, you probably want to use a loop instead. You'll be writing much less, and it's going to be much easier to overlook. First, we're going to look at the for and the for each loops. For loops look a bit like this. For a certain number of repetitions, do a certain thing. For example, we could have for int I equals 0, I is less than 3, increment I by 1. So the do this part of it would be system.out.println execution number I. This is a quite classic design, but your loop might not look exactly like this. You don't have to name your int I, you can name it anything. It's just an int, as I'm sure you've created many before. It also doesn't have to be less than 3. You can put any value instead of 3. And it doesn't have to be less than. It could be equals, smaller, greater, greater than equal, anything. And also I++, which means add 1 to I, is not obligatory either. You can do I minus minus, which is I minus 1, or I equals I plus 2 plus 3 times something. It's up to you. Any mathematical expression. When you run this, what happens is that you create a space, an int space, called I, which starts off with the value of 0. Then you test if I is less than 3, so the second part in the brackets after 4. If that turns out to be true, then you do what is between the curly brackets, so in this case, print out execution number I. Then once you've reached the end of the curly brackets, you go back to the method header and look between the brackets and do the third instruction, so in this case, add 1 to I. Afterwards, you start over again. You look at the condition, so is I less than 3? I is now equal to 1, so it's still less than 3. That evaluates to true, so you then go to the curly brackets and do whatever is between them. So system.out.println execution number I. Once you reach the end of the loop, you once again increment I, who now has a value of 2. And you keep doing this over and over again. You test the condition, is I less than 3? Yes, it is still less than 3. It's 2. So you print out execution number 2 and increment I by 1. It now holds a value of 3. So when you do I is less than 3, that's strictly less than 3. Therefore, it evaluates to false. And what is between the curly brackets does not happen. The loop has ended, and it will now go on to whatever is after that in the code. For each loops are designed for data structures, which are either an array or an array list, usually. It could also be a list. And they're designed along the format that for each object in this data structure, I will do a certain action. Here we are creating an array of strings called data, which will contain the game is on in 4 separate strings. The header of the for each loop you would read as for each string s in data, system.out.println s. What I did with the array might seem a bit unfamiliar to you. It's simply creating the array and filling it at the same time, instead of creating it and having to go back and input the strings in each of the separate spaces. It's much quicker, and I know what the test data is going to be, so I can do it. When you run this code, what will happen is that it will firstly create the array with the 4 spaces to store all the 4 strings. Then the for each loop creates a reference s, which will point to the first object in data, so in this case, the. Then the body of the loop gets executed, so the code will print out the. Then we return to the header again, just as we saw in the for loop. Here the reference s gets reassigned to the second object in the data structure, in this case, game. And then the body of the loop executes again. So we'll print out game. And once again, we go through like this for each item in the list. So s will then get reassigned to is, and the body of the loop will print out is, and then it gets reassigned to on, which is the last one. So it will happen for each of them, and then once it hits the end of the data structure, the loop will end. Of course, you could also do this with a for loop. You could say, execute the number of times that there are objects in this data structure. But for each loops are a quicker way of doing that. You don't have to use them if you don't like them. Everything that can be done with the for each loop can also be done with the for loop. So, as a summary, the for loop comes with an integrated counter, and you can use it whenever you know the number of executions. When I say you know the number of executions, you don't necessarily need to know that it will happen 3 times. You can simply know that it will happen x times, where x will be given by some previous part of your program. You have to be careful when you go through a list and you remove items with the for loop, because it can cause some skipping since your loop doesn't know it has removed something. We'll come back to that later. For each loops are specifically made for data structures and best used to look through the list, because you can't remove anything from a data structure with the for each loop because it follows the thread of the data structure. So if you break the chain, the for each loop will be completely lost and crash. You also have to be careful because it creates a local variable, a new name for what you mean, and you have to be careful when you modify it. See the passing by value video for more information on that. When in doubt, use the for loop because it can be used anywhere a for each loop can be used, but a for each loop can't be used anywhere a for loop is used.